Okay, 2, 2. Your learning target today is to find reference angles in all 4 quadrants. That's easy. Then the second big learning target is to use the special triangles from yesterday What do I mean by special? What made them special? Triangles. To find exact values, I should say exact trig ratios, in quadrants, 1, 2, 3, and 4. Every quadrant. We did first quadrant yesterday. We're going to hit it again today. Okay, so the only thing we're doing in the note here is learning target 1. The learning target 2 is going to be done in the little packet. Okay, reference angle. What is its definition? Reference angle. A reference angle has to be less than 90 degrees, greater than 0. So it must be between 0 and 90, not including 0 and 90. So notice the rounded brackets there. And it has to be made with the x-axis. So between 0 and 90 and made with the x-axis, not the y-axis. So, if I give you a 100-degree rotation, so we're back to rotation, 100 degrees, what quadrant is that going to land in? 2. 100 degrees. Right about there. 100 degrees. We want to find the reference angle. Well, the reference angle is the angle made with that and the x-axis. And it has to be between 0 and 90. Well, that means we are looking for from the terminal ray to the x-axis. How do we figure that angle measure out? Yes, 180 minus the rotation over here. So what is this reference angle? 80 degrees. Very good. So the process is 180, because that's what it would be with the two together. You can see the two arcs by adding up your 180, but I want to take off the 100 that's out there. And we get 80. Okay. Let's say I give you 205 degrees. Which quadrant are we in? .205 lands in. Agree with third? 90, 180, got to go a little bit more. So that's 205. We're trying to find the reference angle. The reference angle is from that ray with the x-axis. So we're looking for this angle here as our reference angle. How do we get that? Thought I heard it. What about 180? Off of So start with the angle, subtract off the first 180 degrees. We're really looking for how much past the 180. So that is 25? 25 degree reference angle. So easy. Reference angles are easy. They're going to be just as easy.
Promise?
Promise? Not lying. Not lying. Today's not my lying day.
1 to 10.
310.
How easy is today?
Today is about on a scale of 1 to 10. I'm going to put it at about a 2.
With 1 being the easiest?
Yep.
What's a little tricky about it?
Nothing's tricky. I never said anything tricky.
Why isn't it 1?
It's fun.
Why isn't it 1?
Because you got to think a little bit. Okay, 310. Which quadrant? Fourth.
Yeah,
We got
4.
90, 180, 270, and then some more.
Still some.
There's 310. The reference angle, again, has to be from that ray to the x-axis. So we are looking for that to be our reference angle. How do we figure that amount out? 360, because if you look at the rotation that's there, what I'm looking for, that's a complete circle, so we're going to go 360 minus the rotation of 310 to see what's left. 50 degree reference angle. And our last one, give you a doozy, 872 degrees. What is its reference angle? Okay, so we got to spin a little bit. Okay. Spin once, we're at 360. Spin a full time again, we're at 720. 872 minus 720, we got to go another 152. So which quadrant will it stop in? 2. So we got to go another 152. But again, we're looking for the reference angle, which is just to the x-axis. How are we going to figure that out? Yeah, what did we do when we were in second quadrant? Right over here. 180 minus 152. Got a 7 there, 8, 28 degree reference angle. So you understand that reference angles are the angle measure from your ray to the x-axis. It's got to be under 90 degrees. Okay. Now the next part, that's done with notes. The next part, we are just doing it. I have a packet for you. We are not doing this whole packet, so don't even think about complaining. 1, 2, 3, 4, 5. 1, 2, 3.
Yeah, what's my actual one?
For you.
I don't.
Very exciting.
Wasn't I even sure to get one night?
Yeah. Maybe a little longer than that.
It's not.
Okay. You'll need a pair of scissors. Share. Cut out just 2 of the triangles down here. Just one set of 2. Grab a pair of scissors. Cut out 1 45 45 and cut out 1 30 60 90. Just one set.
What are we cutting out? These?
One set of triangles at the bottom. 1 30 60 90 and 1 45 45. Yes? Yep.
Are we doing anything else in this packet? Or just kind of shape
Yeah, a little bit. You need 3 colors, but just pick one for now, and then you can share with someone, because you're going to use one at a time.
Oh!
And then you can borrow someone's when they're done with it, because we're going to do 3 different triangles, so I want 3 different colors. So if you just pick one and share among you, you'll be fine. You don't need 3 to start with. You're only going to use one color at a time. Then you have to run back in the box and get a different one. Make sure you're cutting the ones out at the bottom, not the ones at the top.
I got one. Yeah.
Got you covered.
Okay, he wants what first? I want this first. What's up? Good, you never know the first time. How'd you do it? Oh boy.
Come on, let's not take all day.
Schwartz, are you rushing me?
Yes, I am.
You need the
Hustle.
scissors?
Hustle
You need
your
the
butt
scissors?
off. No, I'm done.
Binary, gender, fluid, agender.
That's really cool.
Do they need to be perfect or no?
Still legit, right? You can do that.
Semi.
I don't know if it's worth it.
Done there.
Well, anything you do, Mr. Schwartz, is really brilliant.
Right. So the same exact thing, let's add a couple of things.
Anyone need pencil? First try. You got a yellow?
Yeah.
Anyone need pencil? Yeah, yellow. Anyone need a pencil?
Okay, everybody ready? Let's start with our 30, 60, 90.
Bad news, got it. Alright. 30, 69.
All right, everybody ready? 30, 60, 90, paying attention?
Yeah.
Okay. Okay, we're going to do exact trig values like we did yesterday in the notes. And we got to put side lengths on our 30, 60, 90. What did we decide was going to be best to put on that short leg yesterday so we don't have to do as much reducing? 1. So start here on the short leg, put a 1. What went on the hypotenuse then? It doesn't matter. No, it doesn't have to be the color yet.
Hypotenuse is 2.
Hypotenuse is double. That was 2. And then what was on the long leg?
Square root of 3.
Okay. Square root of 3. So everybody's got a 1, a 2, and a square root of 3 on their triangle right now. Agreed. Okay. Flip your page. We are working our way to creating the unit circle, and you will become very familiar with the unit circle. I have this as my unit circle, which means the distance from the center to the circle is supposed to be 1. Well, when I lay this on here, it was supposed to be perfect. Right now, with the triangle we chose, our distance is 2, but I want it to be 1. So what can I do to scale this down to a 1? What can I do to all 3 values here to scale my hypotenuse, which I have a 2 on, but I want it to be a 1? Any guesses what we can do there? Divide everything by 2. So we're going to divide by 2 and make the hypotenuse equal to 1. What's going to happen to this short leg? Instead of being 1, it's going to be 1/2. And then the long leg, instead of being square root of 3, it's going to be square root of 3 over 2. Okay? So now, we are going to sketch in the 30-degree angle. Make your 30, 60, 90 triangle. What is this ordered pair that's representing our 30-degree angle here? What's the over, what's the up? According to the triangle that's sitting there. How far over am I? How far up? What's this ordered pair? Square root of 3 over 2 is my over. And my vertical is a half. Okay, so based on this ordered pair, because it's on the unit circle, which trig value is attached to this x value here? This is what you gotta have your brain wrapped around. Which trig function is attached to x? Cosine. What's attached to y? Sine. And then to get the tangent, we do y divided by x. Okay, so what we're going to do, flip this back over. It's going to get a little bit obnoxious.
Oh, no.
Okay, we're going to fill in the 30-degree ratios, just like we did yesterday. But put the ordered pair down that we just had. It was square root of 3 over 2 and 1/2. Right next to the 30, because that's the point on the unit circle that the ray passed through. So that means sine is a half. Cosine is square root of 3 over 2. Tangent is y divided by x. I want to show you what happens on a separate sheet of paper so you don't have to do so much writing. So watch what happens. I've got 1/2 divided by square root of 3 over 2. How do I divide fractions again? Multiply by the reciprocal. So I keep the 1/2. I reciprocal that. I get 2 over square root of 3. What happens? 2's cancel, and I get 1 over square root of 3, which we can hit with the 1. But take a look. If I'm going to divide this fraction by this fraction, the denominators are the same, those end up canceling. If you can just remember that shortcut. And you'd have 1 over square root of 3, but we've got to hit it with the 1 because we can't leave that. So if you want to put the 1 over, because it's the y over the x, 1 over square root of 3, and if you hit it with a 1, what are we going to have? Square root of 3 over 3. And then we take the reciprocal of all of these. So 1/2 flipped over is 2. Then we'd have 2 over square root of 3. Hit it with a 1. Yep. If you can see it in your head, that's great. And you don't have to write this down. Hopefully you're getting there. 2 square root of 3 over 3. And then we're going to be clever. We're going to take that original 1 over square root of 3 and flip that over, and we just get square root of 3. Those we had yesterday. Now we're going to take that triangle, flip back over here. We are. Okay. I want you to take this triangle. Now reflect it over the y-axis. Reflect over the y-axis. Okay. Oops. What's my reference angle here? How big is this angle that I've got at the origin? 30 degrees. What's my angle that actually rotates from the x-axis over to that? How much is this? 150. We want 150 here. Everybody see why that's 150? Because I got a 30-degree reference angle, which means this had to be 150 plus the 30 gets me to 180. What's the ordered pair here at 150? Because this triangle is the same triangle I had over here. What's my x value going to be? Negative square root of 3 over 2. It's the same length, it's just in the negative direction. Spencer, you're never going to understand this if you don't pay attention. And what's my vertical? Still positive 1/2. So now I can go to quadrant 2's table, which if you turn the page, here's quadrant 2. Reference angle was 30, but what's my angle measure we just found out? 150. Our ordered pair was negative square root of 3 over 2, positive 1/2. Based on that ordered pair alone, we can fill in all 6 of these. What is the sine of 150 degrees? Which one of these is sine? The 1/2, the y value. Cosine? Negative square root of 3 over 2. Tangent is y over x. We know the 2's cancel out. So negative 1 over square root of 3. Hit it with a 1. Negative square root of 3 over 3. Now flip them all over. 2. Negative 2 square root of 3 over 3 when I hit it with a 1. Can I skip that step? And then negative square root of 3. Okay. Let's go back. Take our 30, 60, 90. Oh. Okay. Take this triangle. I want to move into the third quadrant with it. So we're going to keep the 30-degree angle always at the origin. We're going to reflect it over the y-axis now. Still the same triangle. Always the 30-degree reference angle. So if my reference angle is 30, what is the actual angle rotation into the third quadrant going to be? How do we figure that out? To what? Vince says 210. Is he correct? Because it's 180 plus the 30. This is a 210 angle. What is its ordered pair? Use the legs in the direction. Negative square root of 3 over 2. And then the y value? Negative 1/2. So we're going to go to the third quadrant table. Quadrant 3. We did a reference angle of 30, but what was our rotation? 210. We wrote down the ordered pair. It was negative square root of 3 over 2, negative 1/2. It's the same ordered pair. Same x value, same y value, it's just the direction. So the positive and negative is changing. And now we fill in all 6 of those. So the sine at 210 is negative 1/2. Cosine at 210 is the x, so negative square root of 3 over 2. Tangent is going to end up being, if I look at this one up here, I'm still doing y over x, but it's just going to be positive because I got negative divided by negative. So 1 over square root of 3. So positive square root of 3 over 3. Then negative 2. Negative 2 square root of 3 over 3. And then positive square root of 3. And now we're going to take that 30-degree reference angle into the fourth quadrant. So get the 30-degree angle at the origin. If I start it back here, it's just flip it over the x-axis, reflect down. Let's figure out, it's a 30-degree reference angle, so what's my rotation that's going to take me all the way into that fourth quadrant? 330, according to Crow. And I like it. Okay, what's the ordered pair? It's all about the ordered pair. Positive square root of 3 over 2 because we went to the right. Negative 1/2 because we went down. So notice, x always stays the same, y is staying the same. The only thing that's changing is the positive, negative. So now we go to the fourth quadrant table. 30-degree reference angle is the angle that matches up with 330 degrees. The ordered pair is a positive square root of 3 over 2 for the x and a positive 1/2 for the y. And then fill in your table. Oh, negative, you're correct. The y is negative, it's down. So, sine is negative 1/2. Cosine is positive square root of 3 over 2. Tangent will be negative 1 over square root of 3, which is negative square root of 3 over 3. And reciprocal all of those. Negative 2. Positive 2 square root of 3 over 3. And then negative square root of 3. Okay. So I did want to, I guess you really don't, I was going to have you color each set of triangles in. They make little bow ties. They're all the same triangle. And then pick a different color for the other ones. I guess the coloring isn't that important if you don't want to, but you can. Make it pretty. Okay. Just inside the triangle. All of them. Okay. You're going to finish the rest of it yourself. This one is for the 45-degree reference angle. Oh, let's talk about the triangle first. Let's go back to the, now grab your 45 triangle that you cut out. What numbers were the best to put on the legs yesterday? We put ones there. 1, 1, and square root of 2. But again, I want this to have a hypotenuse equal to 1. So we've got to scale it down. So we've got to do the same thing as we did earlier when we divided by 2, except this time we're going to divide by square root of 2. So that'll make the hypotenuse 1. This is 1 over square root of 2. This is 1 over square root of 2. Let's hit that with the 1 and rationalize. We want to do it every single time. Let's rationalize it one time. So what is that side going to be when I multiply by square root of 2 over square root of 2? Square root of 2 over 2? I think I'll just flip it over and work on this side. So on the legs, we're going to have square root of 2 over 2, square root of 2 over 2, and the hypotenuse 1. So I'll take you through this one, and then you're going to be on your own to finish all the rest of this up. Okay. So now we have a 45-degree reference angle. So in the quadrant, this actually is 45 degrees. The ordered pair here, over and up, both are the same. Square root of 2 over 2, square root of 2 over 2. Going to the first quadrant table, (45 degrees). Ordered pair was positive square root of 2 over 2. Positive square root of 2 over 2. So sine is the y. Cosine is the x. What's tangent going to turn out to be? 1, because the 2's are going to cancel in the bottom. Then you're going to have square root of 2 divided by square root of 2, you're going to get 1. What's cosecant going to be? Think about what it was before we rationalized. Just square root of 2. Just square root of 2. Still a 1. And it's just the same values, just where the negatives belong. That's why it's a difficulty factor of 2. Okay, you are going to finish up the 45 in all 3 quadrants, and then you're going to do the 60 in all 4 quadrants. And then that will leave the quadrantal angles, the 180, the 270, the 360, and we'll catch those on Monday. So I want you to finish up those quadrants and the tables for those values. So you're figuring out the angle measure, the ordered pair, and then filling in the row of the table.
Do we have to draw it?
Please. If you get a visual on this, the more you see this, the more it sticks in and the more you remember it. I think it was Spencer who was saying, because one of these problems came out on the test, and he said all I had to do was see the unit circle in my head, and he got it. Because we do a ton with the unit circle, so yes, please draw them on the circle. It's all there to help you.